So let's actually uh, calculate an example using finding confidence interval using the T distribution. So consider acid rain, which is basically sulfur dioxide in the clouds coming down in the form of acid rain. This is one problem of pollution. Right? So let's look at the measurements in the Bavarian forest. Measurements of the sulfur dioxide in milligrams per meter cube. So they've taken 26 measurements. Okay, find a 95% confidence interval of sulfur dioxide concentration in the Bavarian forest. So here we have to calculate the. So here, first of all, there's 6 times 24. Sorry, 6 times 4 measurements. So n is actually 24. So you can compute the mean. Right? So remember, we're using this formula. We need to use x bar plus minus t alpha 2 SO. So we need to compute x bar plus minus t alpha over 2 n minus 1 s over square root of n. Okay? So first of all, we need to compute the population mean. So this is n already. We need to compute. So the sample mean will be 52.7 plus. So we sum up all the things in this list. 56.4 divided by 24. In fact, that will be 53.92 milligram per meter cubed. And then we can compute the sample. So we need the S, right? We need the S here. So we've already computed the X. We know the N. So let's compute the sample variance. Okay. So remember, the sample variance is just sum over all the measurements squared minus x bar squared over n minus 1. So in fact, when you compute that out, I won't bother to compute it out. But you can put in the calculator and get 101.480. So that means that the sample standard deviation will be 10.07. So let's highlight all the things in yellow we need in the computation of the confidence interval. The last thing we need is this T alpha over 2. This T alpha over 2 times n minus 1. So remember, the degrees of freedom here is T nu here is n minus 1, so it's 24 minus 1, which is 23. Okay, so this is your nu. Okay, so let's highlight that in yellow. And alpha over 2, since alpha here is, since we're looking at 95% confidence interval, alpha here is 0.5, so our alpha over 2 is 0.025. Right? Okay, so then what's our t alpha over 2? N minus 1 then is our t 0.025, 23. Okay, so what's that? Well, now here's how we use the standard T distribution table. So as you can see, the left-hand column is for your n minus 1, your degrees of freedom. So in this case, it's 23. Right? So we go down to 23. See, 23 here. 23. So let's highlight the row. And then see, this is just like the right tail table in for the normal distribution. But in this case, we have so remember alpha over 2 here. This is alpha over 2. Alpha over 2 is 0.025. So we go down here and we look at the intersection, which is 2.609. Okay. Therefore, the T alpha over 2 n minus 1 here is 2.069. 069. Okay. So that's our T alpha. So we have everything to compute the 95% confidence in the true population parameter. When the population standard deviation is not known, so therefore x bar plus or minus t alpha over 2 n minus 1 s equals square root n. Just plug in all the numbers in yellow, and we get 53.92 plus or minus 2.069 times 10.07 divided by square root of 24. So that when we calculate that out, it means that the true population mean is in the interval 49.67 and 58.17 milligrams per meter cube. Okay. So this is the true acid concentration, sulfur dioxide concentration in the Bavarian forest is in this interval, 95% confidence. Okay. Let's do maybe a couple more examples. So let us look at when Peter is a professional dart player. So he wants to find out whether he has a tendency to throw a dart upward or backward. So he recorded 10 of his dart throws for vertical shifts given in centimeters. So these are all his measurements of his vertical shifts in his dart throws. Find a 90% confidence in a mean vertical shift. Okay. So this will tell us if Peter has a tendency to throw either up or down. Okay. So let's again use our formula. The formula is mean plus or minus t alpha over 2 n minus 1 times sample standard deviation divided by square root n. So here we just add up our all our measurements. Of course, n is equal to 10 measurements here. N equal to 10, so let's highlight that in yellow. Sample mean will be minus 0.5, plus all the go down the list up to 0.18 divided by 10, so that will be just 0.055 centimeters. Okay, so we have that. And then we need the variance, sample variance. So when you compute it out, remember it's the sum of xi squared minus x bar squared divided by n minus 1. So that would be just in fact 0.094. So that means that the standard deviation is square root of that. So it's 0.3066. Let's highlight that. And now we need the t alpha over 2 n minus 1. So alpha here for 90% confidence interval is 0.1. So that means alpha over 2 is 0.05. This is t 0.05. So the degrees of freedom is n minus 1. So it's 10 minus 1, which is 9. So we need 9 degrees of freedom. So let's look at our t distribution table. Let's highlight in yellow this time. So degrees of freedom here is 9. And the alpha over 2 we're looking for is 0.05, right? So, and it looks like our value of t alpha over 2 n minus 1 is 1.833. Okay, so this is 1.833. Let's highlight that. So we have everything. So therefore our x bar plus or minus t alpha over 2 n minus 1 s squared n is 0.055 plus or minus 1.833 times 0.3066 divided by square root of 10. So that means that the true mean vertical shift, 90% confidence, is in this interval, right? 0.1227 and 0.2327. So since the confidence intervals contains both positive and negative sides, there's no evidence that Peter has any tendency to throw upwards and downwards. Okay. And let's go to our final example. So John and has two sets of midterm test papers, A and B. Paper A is for class X and paper B is for class Y. Average mark on this set A is 78. However, he wants to know whether paper B has similar difficulty as paper A. So he invited 50 students from class X to take paper B. Okay. Their marks are on paper B was 79.5 with sample variance 24.10. Find the 95% confidence interval of the mean score of paper B taken by the class X students. Okay, so assume that both class X and Y students perform similar on paper B. So again, we need everything. We need x bar plus or minus t alpha over 2, n minus 1, s over school of n, right? So here, n is given to be 15, right? 15. So your new is just n minus 1, which is 15 minus 1, which is 14. Okay, so this is your new, this is your n. We need, so we're given the class average, we 79.675 with variance, so standard deviation given by 24.1 of the sample. So then that will be in fact just 4.9087. So we have everything, okay? Except for t alpha over 2 n minus 1, which in this case alpha is, so we want 99% confidence interval, so alpha is 0.01, so alpha over 2 is 0.005. Okay, so we have t 0.005 alpha n minus 1, which is 14. So we look at our distribution, t-distribution table, go to 14, area to the right, so it's this one, so 2.977. This is 2.977. So we plug it into our formula here, right? So then we have mu must be in between, using all these values here, s and x bar, using this formula. And mu must be in between 75.90 and 83.44. So since confidence interval contains 78, right, then we can conclude that both papers have the same level of difficulty as paper A and paper B.